Okay, we're going to talk about indefinite integrals. So on your graphing calculator, make sure you're in radian mode, and we're going to graph in these different lines. Y equals sine x, y equals sine x plus 4, y equals sine x minus 4, y equals sine x plus 2. And you get the same line, right? Except it's shifted up and down. So can you describe the relative positions? These are a family function, and they differ by a constant, which kind of shifts them up and down. Okay. Write down the gradient of all of these curves when x equals pi over 2. If I plug in pi over 2 in for x, for all of these functions, the slope of all of them is 0. Pi over 2, you can see that's at the top of the curve for all of them. If I use my graphing calculator, we know that at x equals 0, the slope here for all of these is 1. Okay. If I take the derivative of sine, we know that if we take the derivative of sine, we know the derivative is cosine x. So all of these could be written as sine x plus c, where c is just some number that shifts it up and down. Okay. So what does finding the indefinite integral lead to? So the process of finding the indefinite integral of a function leads to the family of functions that differ by a constant c. Okay, and we know the antiderivative of cosine x is equal to sine x plus c. So we're basically doing antiderivatives. We did this last year in SL2, so it's pretty much, this should be a review from what we did last year. However, last year we did not do antiderivatives of trig trig functions or exponential functions. I'm sorry, logarithmic functions. Okay. So so the antiderivative of x squared, and x cubed is 1/2 x squared, 1/3 x cubed, 1/4 x to the 4th. So the antiderivative for x to any number is going to be 1 over n plus 1 x to the n. Okay. Remember, we use capital F for antiderivative. Okay, and all these formulas are in your formula packet. Same thing. Okay. You may want to check your work. Okay, so what is the antiderivative of 1 over x? Well, 1 over x, the slope at 0 is undefined, isn't it? So we can't, it doesn't work. So, but we learned in chapter 10 that the antiderivative of 1 over x is natural log of x. Okay. So, but we can't have this part, so we have to do absolute value, because we can't have any negative x values when we're doing natural log or log. So here are the antiderivatives of sine, antiderivative of cosine, antiderivative of 1 over cosine squared x, antiderivative of e to the x is e to the x. Okay, there's some chain rule stuff. Okay. Okay, so what are the antiderivative rules? They're all right here, and they're in your formula packet. Okay. So you might want to hit pause if you want to copy this down. The antiderivative represents the inverse of a derivative so that we can evaluate using the inverse of all the derivative rules. Okay, so here's some examples. Okay. So here's my derivative function is 2 minus x over 3, right? So if I'm going to take the antiderivative, I'll get the original function. So the antiderivative of 2 is 2x. The antiderivative of x over 3 is the x power increases, and we multiply by a half, right? And then to find the c value, we plug in 1 in for x and 3 in for y, and then we get our c value. Okay. Hit pause if you need to. Okay. Okay, remember to hit pause if you want to check your work. Okay, here we had to do some U substitution. Let me know if you need help on number 9. Okay, last 2. Okay.